This is the most basic presentation on biochemistry. However, this is also perhaps the most important. In order to understand this presentation, it is extremely important that you listen to the audio in addition to what is written on the slides. Spectrophotometry deals with color and light. First, let's understand what is spectrophotometry. Very simply said, we try to measure the amount of color in a solution. This is what is spectrophotometry. The more important question, however, is why do we try to do this? Let's try to understand the problem in front of our hand. In laboratories which are using spectrophotometers, in the laboratories where they take blood samples from patients, the labs are basically trying to find out the concentration of different analytes in the patient serum. For example, the lab is trying to find out how much glucose does this patient blood contain. It would be really nice if the lab could simply look at the blood and reach a decision on the basis of its color that this has 100 glucose or this has 200 glucose. However, we know that this is impossible. This is impossible because simply by looking with our eyes, we cannot find out how much glucose, how much cholesterol, how much triglyceride, how much sodium, etc. is present in a solution. Therefore, we need a scientific law which can help us in finding out what is the concentration of different analytes in a particular sample, and in addition to the law, we need a method of measurement. The law is Beer-Lambert's law and the method is spectrophotometry. Now, the most important measurement that we make for a biochemistry assay is the absorbance. Look at this diagram. On your left, you see a light source, which is typically a lamp or an halogen lamp. In the middle is where you will have your flow cell or cuvette, which will contain the liquid that is to be measured for absorbance. And on the right is your detector. Typically, the lamp will give light which will fall on the sample. If the sample has a dark color, then a lot of this light will be absorbed and a small amount will be transmitted to the detector. And if the sample has very light color, then almost all the light would get transmitted onto the detector. By measuring the amount of light which passes and gets transmitted, we have an idea about the light which is absorbed. Less is the transmitted light, more is the absorbed light. So a spectrophotometer works on this principle and it simply measures the amount of light absorbed by the sample. And then we can apply the Beer-Lambert's law, which is quite simply saying that absorbance is proportional to the concentration when wavelength and path length is constant. To speak very simply, more is the absorbance, more is the concentration, less is the absorbance, less is the concentration. This will become a little bit clearer when we do an actual example. But just try to understand that Beer-Lambert's law is quite a simple law which simply says more concentration, more absorbance, and vice versa. Now, what is absorbance? Absorbance is nothing but the amount of color present in a sample. Rather than trying to understand the physics behind absorbance, I think it's more important that we understand that very simply said, More is the color in a solution, more is the absorbance. Less is the color in a solution, less is the absorbance. So if you take some water and put 5 drops of ink, it will have a slight blue color. And if you put 20 drops of ink, it will have a dark color. And if you put 50 drops of ink, it will have a very dark color. This is what the Beer-Lambert's law says, and this is what the absorbance says. 5 drops of ink, less color. 20 drops of ink, more color. 50 drops of ink, very much color. 5 drops of ink, low absorbance. 20 drops of ink, certainly more amount of absorbance, and 50 drops of ink, a lot of absorbance. If you know how much absorbance, you can measure how much ink and vice versa. Another issue that comes here is that one must remember that we can only compare one color at a time. The human eye can generally see between 400 and 700 nanometers, 400 being violet, 700 being red, and then we have the ultraviolet and the infrared range. However, one cannot compare the absorbance of blue color with yellow color because a dark yellow can have more absorbance than a very light blue. So therefore, we always compare the absorbance only at one wavelength or only at one color. This is why in a spectrophotometer we select the filter or the wavelength at which the color is being read or the sample is being read, and this corresponds to the exact color that we want to read within the sample. Before we go further, one more thing that we must understand is that what is a reference standard? A reference standard is a solution of a chemical assumed to be absolutely correct as to its concentration and identity. Let's go back to the example of the ink that we discussed during the Beer-Lambert's law. We discussed that 5 drops of ink in 1 glass of water will produce a light blue color, and 20 drops of ink in 1 glass of water will produce a darker blue color. We also discussed that spectrophotometer can measure absorbance, and absorbance is nothing but color. So a spectrophotometer is also a colorimeter which measures the amount of color. Let's say we take a glass of water and we put 5 drops of ink and we run this sample in a spectrophotometer. Typically, what we will get will be an absorbance of, let us say, 0.5 units. Now, if we put the other solution which has 20 drops of ink, what we will get will be an absorbance of 2 units. So 5 drops was giving 0.5 absorbance, and therefore 20 drops, which is 4 times the drops, will give 4 times the absorbance or 2.0 absorbance. Now if we take an unknown solution and we check it and we see an absorbance of 0.5, then we know that 0.5 always corresponds to 5 drops of ink. If we get an absorbance of 1.5, then we know that because 0.5 absorbance means 5 drops, therefore 1.5 absorbance means 3 times of 5 or 15 drops. In this case, the fact that 0.5 was the first absorbance that you got with a known amount of 5 drops makes 5 drops as a reference standard. I think the best way to explain the Beer-Lambert's law is with an example. Let us take a real life case. A typical kit of glucose was opened and In that, we got a standard with a concentration of 100 milligram per deciliter. We ran the standard on our kit and checked the absorbance on a spectrophotometer. We got an absorbance of 0.4. Then a patient sample of glucose was measured and the absorbance of that sample on the spectrophotometer came 0.3. The question is, what is the concentration of this patient sample? I would like you to read the question again. Once you have read, then we can go further. So let's go further. Now, the most important measurement that we make for a biochemistry assay is the absorbance. Look at this diagram. On your left, you see a light source, which is typically a lamp or an halogen lamp. In the middle is where you will have your flow cell or cuvette, which will contain the liquid that is to be measured for absorbance. And on the right is your detector. Typically, the lamp will give light which will fall on the sample. If the sample has a dark color, then a lot of this light will be absorbed and a small amount will be transmitted to the detector. And if the sample has, so the patient sample when read on the spectrophotometer was giving an absorbance of 0.3. So simply multiply the factor by 0.3, in this case 250 into 0.3, and the answer is 75 mg per dl. So 0.4 absorbance meant 100 mg per dl, therefore 0.3 absorbance means 75 mg per dl. This is the way in which chemistry analyzers apply the Beer-Lambert's law for estimation of analytes in patient serum.